All right, we're going to be going over homework 15, problem 5. This is my submission for my second submission for the video review for exam number 3. I noticed that somebody had already done problem number 18 from Webwork 16 after I handed that in. So always keep an eye on that sign-up sheet. So first thing that they're looking for in this problem, we're going to be solving this initial value problem. And the first thing we're going to do is find the capital Y sub s by taking the Laplace transform of yt. So I took the Laplace transform of this, and there's some standard forms that we know here. The Laplace of y prime is capital Y s squared, y0 s minus y prime 0. This is an important step to keep an eye on. I always mix those two up, and then obviously that'll lead to you not getting the right answer. So keep track of that. It's always the y without the prime before you get y prime. And then the Laplace of y prime is ys times s minus y0. And then we're going to multiply that all by 5 because that's our coefficient on the y prime there. And then since this is an initial value problem, they gave us values for y0 and y prime 0. So right after this step, I just went ahead and made those substitutions here. I factored out the ys and also brought in the values from the initial values, and we end up here. So now I'm going to isolate ys, and to do that I first add or subtract over the terms that aren't multiplied by ys, and then after I do that I'm going to divide through by the term that's multiplied by ys, and we end up here. And that's okay, that is the answer, but it's not quite in the form that I want. At this point, I'm going to start looking for partial fraction decomposition. So I actually combined terms here and got to this zone. And then from there, I got to here. And the reason I stopped here was because I see two partial fraction decompositions. I factored out that E there. I saw two partial fraction decompositions, which then I took care of down here. Which I'm not going to spend too much time in this area because we should all be pretty comfortable with our partial fraction decompositions, but at this point we've been doing a lot of them. So I found out that the 2s minus 10 over our denominator is going to just simplify down to 2s, which is nice, and then that 1 over our denominator ends up being negative 1 over 5s, and then 1 over 5 times s. 5 times s minus 5. And then I wrote the final form of ys before I go ahead and take the inverse Laplace. And I wrote this in a way that was going to help me identify the Laplace transformed inverse. I wrote this in a way that would help me identify the forms that would help me recognize our common inverse Laplace transform. There we go. That's how the words go. And I rewrote this now with the inverse Laplace notation, so anyone looking at the problem would know what I was doing. You can see that here. I think that is important. You don't want to just go skipping from the y of s right down to y of t, because I just think that's not very clear. So some people like to leave the e function outside of the Laplace transforms, or not outside of, but not part of the fraction. I actually see it better when it's written like this. And I misspoke. It's never going to be outside the inverse Laplace. It's always going to be inside the inverse Laplace, but just not in the numerator. Some people like to write it not in the numerator. I like it in the numerator. So I write it like this, and it helps me see it. We know by having that e to the negative 2t in the inverse Laplace that we're dealing with a unit step. So when you take the inverse Laplace of e to a power, you get your unit step, which I have here. And then this essentially is the same as the inverse Laplace of 1 over s multiplied by 1/5, negative 1/5, end up there. And then we have the inverse Laplace of e to the negative 2t over s minus 5. This has the same unit step as this function here, which is why you can see I factored that out in this step here. But you can look at this as 1 over s minus 5. We know that an s minus 5 in the denominator is going to lead to the inverse Laplace equaling e to this power there, a, times t. So that is how we end up here. And always remember, when you have a unit step function, your t values within your function are also going to be subjected to that unit step as well. And then, last but not least, we have 2 times the inverse Laplace of 1 over s, which is just going to lead to us getting a constant. And that is where we end up there. And then I rewrote that just to be a little bit easier to look at. And then the last thing that this problem asked us to do was write that formula as a piecewise defined, which can be really easy, but could also lose you a lot of points if you're not paying attention to what's going on. You see that this 2 is not affected by the unit step, so we know that the function is going to be just 2 until the unit step, which our unit step starts at 2. That negative 2 shifts it to the right. So we're going to go along, y is going to be a value of 2 until x equals 2. And then once we get to x equals 2, the function is going to go up 2. We're not shutting off the 2. We're not losing the 2. So we're only adding to that, which is why I end up with the 9/5 here, right? 2, if we're going to give that a common denominator with 1/5 here, that's going to be 10 over 5. And then, so 10 over 5 plus a negative 1/5. That's where we end up with our 9/5 here. That could be a little hard to look at. And then that's just the rest of the function that we have in the brackets up here. And that is from 2 onward. So that is all the pieces of this problem. This is a pretty big problem. I moved through it kind of quick, but I know that I struggled with this problem the most in this area here. So initially, when I did this problem, I got to this area here, this first form of y sub s, and got stuck because I didn't know what to do from there. Writing the parts of y sub s down in a way that allows you to identify first your partial fraction decompositions is important step number 1. So you want to be able to identify your partial fraction decompositions, and then after you do your partial fraction decompositions, you're not out of the woods yet. You need to rewrite it in a way that allows you to identify your common inverse Laplace forms. So those 2 steps can cost you a lot of time and could cause you to be stumped. So you can see here, when I first answered this problem on the Webwork, why I would have had a lot of trouble, because I'm doing an extra partial fraction decomposition to get to the same point, and that's just, adding more work for myself. And then after doing it that way, I'm not ending up with a form of y of s that's easy for me to identify the inverse Laplaces. So, like I said, if there's anything, one key takeaway is just be conscious of the step that's coming next, and you'll be able to save yourself a lot of time and a lot of trouble. Hope this helped. Good luck on exam 3, and thanks for watching.